Lastly, we come to miscellaneous question or some practical problems about sine, cosine, and tangent theta. So in this three, trigonometry ratios are very important in the history because it helps to find the length, the side, the angle, etc. So which is very important in engineering, architecture, etc. So in some question, it tells you some ideas behind it. But anyway, let's take a look. In number 2 is a very easy question. There's a photo frame lying on a table, which makes an angle theta on it, and you want to find out. And according to the question, so you see there's a right angle triangle. Towards theta, 30 is opposite side, and can you identify 45? Yes, it's hypotenuse. So with opposite hypotenuse is sine cosine tangent? Yes, sine. So that's why sine theta will be 30 over 45. In order to remove the sign, you use shift sign, the button in your calculator, shift sign of this big fraction, and see whether you can obtain the result very quickly. I leave the answer for you to fill in. Next, let's move to number 4. And once again, if you have several triangles, you better list out how many or which of them are right angle triangles. So you have triangle ABD, and you have triangle ABC as well. And which I find triangle ABC is better because it gives you 18, actually in a better way, 18, 36 degree, and you have this triangle. Next, in triangle ABD, you only have 12. And secondly would be, when you look at two right angle triangles, you bear in mind that so we need to look at the common side, which is a very important technique when you deal with question involving two triangles. This time the common side will be AB, so that's why we need to find it out. As you see, part A hints you already. And then now we come to take a look in the big one first, which is in blue, because it's more informative. In A, you have, according to 36 degree, AB is, what side is it? Yes, opposite. While 18, yes, hypotenuse. Opposite hypotenuse, O and H, so what's that? Sine theta. So that's why at first we have sine 36 degree equal to opposite side, which is AB, divided by 18. 18 sine 36 degree is your AB. So once again, it's not the end of the question. I suggest you write a long answer first, which gives you 10.5801. So that's why AB will be 10.58, 6 cm, correct to 3 sig figs. Next part will be harder because you are asking to find DAC, which I mark in red. But this angle is not good because it's not one of the angle in a right angle triangle. So that's why you have this choice. We don't look at this one, but we look at the big one. But looking at this big one, there's a drawback because you don't know this angle BAD here. So that's why I don't consider it. Secondly would be, if you want to find this one, and you see there is a 36 degree here, so together, add up together, it gives you exterior angle of triangle, angle BDA. And this one may be good because according to 12 and AB we have just find, you can find the angle BDA over there. So see whether you can manage the idea in my thinking. So that's why in order to find angle DAC, I shift my focus into finding angle BDA first. And then so I use the space on the left hand side for demonstration. I will say in triangle BAD, which you have this angle, AB is still opposite side, so this one is correct. 12, the 12 is hypotenuse. Is it alright? So this one is again sine theta, sine angle BDA this time, equal to AB, which is 10.5801, divided by 12. Now take out your calculator, find this fraction, then shift sign and see whether you obtain the result, which is, okay, let's check by calculator together. Which is angle BDA equal to 61.8451 degree. So as a result, angle focus is called DAC plus 36 degree equal to 61.8451, and now you can get the result of angle DAC quickly. So in this question, you will see or revise again the technique when you have two triangles, two right angle triangles in a question. The technique will be look at the common side to do it. In some occasion, or this one is harder, which you need to consider exterior angle of triangle in order to solve the problem. Lastly, let's take a question which is not about right angle triangle in the beginning, like number 8. So as shown in the figure, you see there is a trapezium, and now you are going to find angle D as required by the question. So in this question, so the biggest problem is about finding angle, but without any angle, right angle triangle. So that's why the easiest trick will be draw the right angle triangle by yourselves. So I draw two heights in the trapezium. So you bear in mind that if it's 3 here, so it's also a 3 here. So for our convenience, I mark it as light E and F in the figure as shown. So now in order to find the angle D, and now I've got, it's 2 cm here, so that's why CF is 2, B is also 2. So in this triangle called CDF, I've got a 2 already. Now I'm asking if I can find FD, then I can find the angle D. So that's why FD and angle D, they are related to each other. And in order to find FD, then you will see that this side EF is a 3 cm, FD is something we want to find, full length is 15 cm. So that's why it goes to, can I find out AE in the question? If yes, then I can find FD. If yes, then we can find angle D. So this is the procedure of doing the question. So that's why now I move to look at the question in triangle ABE first. In triangle ABE, you have BE here. So with A, my focus is AE, 21 degree here. According to it, I have B. Question tells me that B is 2. Now I need to identify the nature of the side. B is opposite. And I want to find AE, which is, yes, adjacent to it. So that's why I need to use sine cosine tangent. Yes, tangent. Tangent 21 degree would be 2 over AE. So again, if it's unknown, AE in denominator, move it to the left hand side first. And now, can you check out what is AE here? Yes, which is 5.21018. And that's why now I can proceed to step 2, which is I want to find FD, which is given by 15 minus AE. So we found it already, and minus 3. And now can you get the result of it? Okay, so let me check. Which is equal to 6.7898. And finally, then we come to triangle CFD, where you draw a triangle as a reference, CFD. 2 is given already, FD is 6.7898, and you want to find angle D. According to angle D2 is, yes, opposite. FD is, yes, adjacent. That's why finally it goes to tangent angle D is equal to 2 over 6.7898. And you use your calculator to get angle D, and don't forget to write The reference correct to 3 sig fig finally in the answer.